Hello everyone and welcome to the Phosphorus Digital Week. To present myself quickly, I'm Justine Martini, Junior Product Manager here at Phosphorus, and I will be the animator of this session. So today we are excited to present a crucial topic in mineral nutrition, phosphorus and digestibility, an expert review. This webinar series addresses key challenges in livestock farming, including aquaculture, poultry, swine, and ruminants. Today, we will speak about mineral digestibility in livestock, focusing on phosphorus and calcium. Our speaker today is Margot Pujol, Technical and Marketing Manager at Phosphorus. She works for Phosphorus since 2020, so enjoy her technical expertise on minerals during 40 minutes. Finally, we will conclude with a 10 minutes Q&A session where you can ask Margot all your questions. Don't forget to access to the chat, you need to click to this icon. So thank you for being here, and we hope you find this session both informative and engaging. So please, Margot, you can start.
Thank you very much, Justine, for the introduction. So yes, today our topic will be to talk about phosphorus digestibility and some little review about some aspect in multi-species. So I will share my screen. There we go. Up. Is it all good? Perfect. Okay, let's start and let's talk about phosphorus and digestibility. So before starting, let's have a reminder about the differences between digestibility, bioavailability, and retention of minerals. When we talk about digestibility, we mean that it is the extent to which a mineral is released from food during digestion and becomes available for absorption in the intestine. When we talk about bioavailability, we talk about the proportion of a mineral that is absorbed and utilized by the body for physiological functions after ingestion. And finally, when we talk about retention, we discuss about the proportion of an absorbed mineral that is stored and maintained in the body for metabolic functions instead of being excreted. So let's talk about this retention. When we have a look at this table here, we can see that between macrominerals such as phosphorus or microminerals such as zinc and copper, we can have variability in terms of retention of the minerals. What we can see, for example, is that for phosphorus, it seems that the ruminants have a better retention than the monogastric for pigs and poultry. Versus, we see that for zinc and copper, it seems to have a better retention, for example, for poultry than for ruminants when we talk about zinc. So, in fact, there is a large variability of retention depending on the mineral and also depending of the species. But most minerals are retained at less than 50% in the animal body. There was a study made recently in 2022 by two searchers, Lauren Byrne and Richard Murphy, where they investigated about factors or parameters that could contribute to reduce the mineral bioavailability and retention. And today we are going to talk about three of those parameters. First of all, we are going to talk about the non-consideration of animal physiology. Then we are going to talk about excess supply, and finally about minerals interactions. Let's start about the non-consideration of animal physiology, and we will start to talk about mineral absorption in aquaculture. Some minerals can be absorbed directly from the water through the gills of the fish or the shrimps, such as the magnesium or the calcium, as they are available in the water. In contrast, the phosphorus concentration in water is very low. That's why it needs to be added directly through the diet in order to answer to the animal needs. So the calcium supplementation is not necessary in aqua diet. Indeed, it can decrease phosphorus digestibility, underlying the deleterious effect of calcium on phosphorus absorption. For example, here in the graphic on the right, we can see that we have three different diets. The first one is diet formulated with monocalcium phosphate, MCP, a second one with monosodium phosphate, MSP, and a third one with monosodium phosphate plus the addition of calcium carbonate in the diet. What we can see is that the phosphorus digestibility is better with monosodium phosphate, which is what we could expect because it is the most digestible phosphate for the monogastric species. But when we add calcium carbonate in the diet, we can see that it has reduced the phosphorus digestibility. So, in fact, the most suitable feed phosphate to aquatic species will be monosodium phosphate or monoammonium phosphate because this is phosphate without calcium. And as we said before, the calcium in diet is not specifically needed. Now, let's talk about the piglets and the pH in the stomach. In piglets, the stomach secretes less hydrochloric acid than an adult pig, and its pH can be between 4.5 to 7 versus 2.5 to 4.5 in fattening pig. This high pH at post-weaning in piglets can lead to low protein nutrients digestibility, low protein and nutrient digestibility, and also reduce the enzyme activity. As we can see here in the graphic, just after the post-weaning, we have a decrease in terms of protein mass, but also in terms of the intestinal health. At 47 days, so during the pre-starter phase, piglets meet a high pH variation. The protein digestion is linked to the pepsin secretion. The higher the pH, the less it is secreted. Pepsin is most active in an acidic environment with an optimal pH range of 2 to 3.5. And consequently, its activity can decrease rapidly at higher pH level, such as for piglet after the post-weaning. We can also look at another parameter, which is the acid binding capacity. It is a parameter that will measure a feed ingredient's ability to alter the gastrointestinal pH. So the limestone, that is a common mineral in swine diet, has a high acid binding capacity, which can increase the stomach pH and potentially decrease growth performance. So which solution to prevent pH increase after the post-weaning? First of all, consider that there is a post-weaning transition and there is variability of the pH at this phase. Secondly, formulate with a lower amount of limestone, specifically in the pre-starter feed. As we can see here, for example, in the table, we can see that when the calcium carbonate level is increasing, the acid binding capacity is also increasing. That's why reducing its incorporation can limit this pH increase after the post-weaning. Another element to look at and solution that could help is formulate the pre-starter feed with taking in account the acid binding capacity of all the ingredients. If we see here about calcium carbonate, we can see that it has a high ABC level. And if we look about phosphate, in fact, we can see that it seems that the monocalcium phosphate is more adequate for the piglets than the dicalcium phosphate, as we see that the ABC is lower. And another element to take into account is the source, is where you source your limestone. The best will be to have a high digestible limestone in your diet. Now let's talk about ruminal bacteria for cows. If we take a cow of 650 kilograms, for example, we know that she has maintenance needs, that is for phosphorus, 29 grams of phosphorus per day. Additionally, there will be a need for the ruminal bacteria, which is around 58 grams of phosphorus per day. And then if we talk about a cow, for a milking cow, there will be phosphorus need for the milk production, that is 2 grams of phosphorus per kilogram of milk produced. And if we take a cow that is approximately producing 29 kilograms per day, then in total, only for the milk production, she will require 58 grams of phosphorus per day. So in total, a cow will have 145 grams of phosphorus per day of need for her maintenance, for the ruminal bacteria functionality, and for the milk production. If we make a specific focus on ruminal bacteria, what we need to take also in account is that the phosphorus must be soluble to be well utilized by the bacteria, because its availability is going to impact the cellulitic flora activity. Meaning that when you have less soluble phosphorus, you have less available phosphorus, less cellulitic activity, lower fiber valorization, and lower animal performance. In a study made by Ramirez Perez in 2007, we can see that he gave two kinds of the diet to ruminants. One with a high amount of water-soluble phosphorus and another one with water-insoluble phosphorus. And in this graph, in fact, we can see that as high is the water-soluble phosphorus in the diet, we have also a better ingestion of the diet. So what does it mean? It means that with a high amount of phosphorus soluble in the diet, you could have a better microbial activity in your rumen, consequently increase the feed intake, and also increase the milk production or the average daily gain if we talk about fattening cows, cattle. So to conclude about this first part, what we need to think about is that physiology is going to influence how minerals are absorbed. So our recommendation would be to control the stomach pH post-weaning for piglets, support ruminal bacteria with soluble phosphorus in the diet, adapt the phosphate to the species, such as we should prioritize MSP or MAP for aquaculture and MCP for pigs. Secondly, let's have a look about excess supply and how there is this interaction between the formulation and the mineral excretion. When you talk about the animal needs, if we are inside of it, it is perfect, but if we are below, we are going to talk about phosphorus deficiency, and if we are above, we are going to talk phosphorus excess. When we have a phosphorus deficiency in animals, it can lead to a reduction of phosphorus in blood, a loss of appetite, and growth and bone disorders such as fractures, reproductive issues, and a decline in performance levels. If you have a phosphorus in excess, this could lead to environmental pollution and financial waste. Let's have a look about the environmental pollution. Today, if we look about Europe, the main countries with high level of total phosphorus in soil will be UK, north of France, north and south of Germany, Belgium, the Netherlands, Denmark, Catalonia in Spain, and north in Italy. What we can see as well from the same study is that there is a relationship between phosphorus pollution and livestock density. So the areas with the highest level of total phosphorus are also those with the high density of livestock. There was a study done by Walk in 2016 where they compared the variability in the diet between the formulated and the analyzed situation. If we look about phosphorus, we see that there is some variability, but they are not so high. But then what could contribute to phosphorus release in the environment? We need to look at the calcium. In fact, in this same study, Walk highlights the fact that there is a high variability between the formulated and the analyzed total calcium. In fact, actually, there is a current oversupply of calcium in feed diets by 25%. If you take an example of formulation at 0.80%, you could find in your analyzed feed 1% of calcium instead of 0.8%. Another study made by Schotters, an internal study, show that calcium can also be added at too high doses, decreasing tibia ash content in broilers. So really important to not only think about phosphorus, but also the other minerals such as calcium that could impact the excess supply. Secondly, if we look about the recommendation, for poultry or pigs, we can see that the feed tables all around the world, such as FEDNA, CVB, NRC, INRA, they do not agree on the calcium, on the digestible available phosphorus, or even on the calcium phosphorus ratio. For pigs, it is the same. We see that the feed tables do not agree to give the same value for those elements. So how could we do? First of all, I have a question for the participants of this session. You will see a pop-up in this presentation, and you can answer the question: how do you formulate in your diet? Is it with digestible phosphorus, available phosphorus, or other? I will give you 1 minute, and then I will continue. Ok. Pour combien de réponses?
Maintenant, c'est à l'équilibre. 6 réponses. Là, de nouveau, P digestible à 9 réponses.
Okay, so we see that in the results, we have approximately a balance between phosphorus digestible and phosphorus available. So we'll have a look at it, how to define the digestibility and the availability of phosphorus. When we talk about availability, we talk about an indirect measure, but still used a lot, for example, in poultry. It is an indicator of the use of a nutrient based on a predefined criterion, frequently the bone mineralization, such as ash content, bone strength, or biological data, such as the performances for the body weight gain, or even the phosphorus in the blood. It is, for example, a parameter that is used in the Spain table, such as FEDNA. Another parameter that we are looking at, that can be looked at as well, is the relative biological value, RBV, that can be used in all species. It is a parameter that is measured the phosphorus bioavailability with a reference considered 100% bioavailable. Usually, it's on the base of monosodium phosphate. It is a value that is mainly used by the French tables, such as the INRA, INRA feed tables. But the main disadvantage of these two methods is that it is not standardized, and thus the criterion and the reference may differ. Now let's talk about digestibility. The digestibility is more a direct measure that can be used for swine, poultry, and ruminants. So normally we take in account the phosphorus intake and the excreted one. In swine, we mainly talk about total tract digestibility or standardized total tract digestibility. The second one is going to take in account, in addition, the basal endogenous losses. And for poultry, the WPSA Association have formed a group of experts that put in place methodology and recommend the use of pre-cecal digestibility. So the term of digestibility is a parameter that is mainly used in the CVB or the FEDNA feed tables. This method, like the bioavailability, gives a unique phosphorus and calcium value for each feedstuff, regardless of the other components of the diet. So what could be the solutions in the future? The best would be to have a standardized digestible phosphorus that is the same for everybody all around the world, and a digestible calcium. The digestible calcium today is not yet available, but we know that some researchers, such as the Dr. Rosilena Angel, is working on a way to formulate in the future with digestible calcium, first in poultry, and we hope in the future in swine. Another solution or another thing to think about is taking account the mineral interaction in the gut, such as the calcium phytate insoluble complex. And we are going to talk about this aspect just after. So to conclude about this second part, the excess supply impacts mineral efficiency and the environment. So we need to limit oversupply by adjusting the formulation, look at what has been analyzed compared to what was expected, formulate according to a standardized digestibility. That would be the best if we could do that in the future. And choose high bioavailability sources to reduce excretion and cost. Now let's have a look at the mineral interaction. And have a look about the calcium phytate complex in monogastrics. First of all, let's talk about phytic acid. The phytic acid, so the vegetal phosphorus, can represent an anti-nutritional factor. Under acidic pH, so in the stomach, it can have the capacity to bind with basic amino acids and proteins, forming protein phytate complexes. When the pH gets above 4, the phytic acid has the capacity to bind with calcium minerals, forming very stable complexes, decreasing their ability as well as the availability of the phosphorus. The stability order of the phytic acid with minerals is first with zinc and copper, and then with calcium. But in fact, if we look at our animal diets, we see that they contain a high amount of calcium compared to other cationic minerals. That's why the phytic acid complex mainly occurs with calcium in the small intestine, forming insoluble calcium phytate complex. So let's have a look at this picture. When the phytate or phytic acid is going to enter the stomach, there will be the action of the phytase, who will release a part of phosphorus molecule. Then the nutrients will go to the intestine. This is where your pH is going to increase. When your pH is going to increase, you have the possibility that the calcium is going to bind again, so recomplex again, with the remaining phosphorus molecule that has not been yet released by the phytase. It will create calcium phytate insoluble complexes that will not be absorbed by the animal and only excreted into the feces. So these calcium phytate complexes has a negative effect on the phytase efficacy and on the vegetal phosphorus digestibility. So, which solution to prevent the calcium phytate complex? First, consider the mineral interaction in the gut. We need to think more about this aspect. Secondly, formulate with digestible calcium. We need to better understand the calcium source and its quality. Thirdly, we can talk about solutions or innovative solutions. For example, in Phosphia, we have developed recently, or since 2022, a new phosphate that is called calcium humophosphate and branded under the name Humifora. This phosphate, compared to classical phosphates such as MCP or DCP, will have specific chelating properties. It will have the capacity to bind with some cation minerals in excess, such as calcium, occurring as an effective calcium trap. Consequently, it will help reduce the occurrence of insoluble calcium phytate complex and increase the vegetal phosphorus digestibility in the intestine. We have done many trials behind us about this phosphate, and when we did a trial in a broiler, we had two diets, one formulated with classical phosphates such as MCP, and another one formulated with calcium hymophosphate. And what we saw is that the phosphorus digestibility of the total diet, so meaning also the vegetal phosphorus digestibility, has been significantly improved. So one of the other solutions could be to formulate tomorrow no more with MCP or DCP, but with calcium hymophosphate in monogastrics in order to prevent this calcium phytate complex. As a last subject, we can talk about the reactivity in mineral feed and more specifically in ruminants. The mineral reactivity refers to the ability of a mineral to chemically interact with other dietary components. It is measured through the temperature rise at 5 minutes due to the reaction between phosphate, water, and magnesium oxide. If we look, for example, here at a mineral feed, we can see that there is a high incorporation of the phosphate, but also other elements such as magnesium. You have the risk to have an acido-basic reaction between the magnesium and the phosphate. And this reaction could lead to an inactivation, for example, of the vitamins. But first, how to define a phosphate? When we talk about a phosphate, we say that it contains phosphorus, which is a macromineral, but also other elements such as water, calcium, iron, etc. And what we need to take in account as well is that when we talk about the phosphate, the phosphorus itself, we can find inside this phosphate MCP, DCP, or TCP molecules. So it's a kind of tricky because you think about the product MCP, but we can talk also about MCP molecules. But the only molecules that can exist in a phosphate, it is MCP, DCP, or TCP. About product, we will talk about the classical ones such as MCP, DCP, or MDCP, but the MDCP, monodicalcium phosphate, it's not a molecule, it is only a product. Before measuring the reactivity, and why am I talking about those different molecules, we can estimate the reactivity through a main parameter that is the phosphorus solubility in the water. The phosphorus solubility in the water is going to reflect the phosphorus proportion under MCP molecules. The MCP molecules are highly soluble in water. So, for example, if you look about a product with MCP, so the product itself, the phosphate MCP, you will have a phosphorus solubility in water that is most of the time superior at 75%. When you are going to formulate with a DCP phosphate, you need to take in account that you have a phosphorus solubility in water below 10%. And for the MDCP product, it is in the middle. As you can see, a DCP phosphate will have a higher amount of DCP molecules and lower amount of MCP molecule, whereas the MDCP or MCP are going to be composed of higher amount of MCP molecules. So high solubility means high quantity of MCP molecules, high reactivity, and high digestibility. When we want to categorize a phosphate, most of the time we base it on the Commission regulation in Europe. They characterize the inorganic feed phosphate based on calcium-phosphorus ratio. So when you have this ratio below 0.9, you will talk about monocalcium phosphate. When it is above 1.2, you will talk about dicalcium phosphate. And when you are between those two numbers, we'll talk about monodicalcium phosphate. So, going back to the reactivity, it is important to adapt the phosphate to the use of the final product. So, for example, in order to have a controlled reactivity, for minerals and mixtures, mineral mixtures or leak blocks, you need to take in account the good phosphate. So, for example, if we talk about loose leaks, leak buckets, or compound feed, for monogastric, for example, you can use MCP, classical MCP phosphate. With high reactivity, there is no issue. But if you are going to formulate a phosphate for mineral or premixes or leak blocks, we recommend to use medium or low reactivity phosphate, such as MDCP, Neophos, which is one of our products, which is sodium calcium phosphate, or DCP, which has a low reactivity. Another solution could be also to use magnesium phosphate. In Phosphea, we have MAG26. And why magnesium phosphate is interesting is because the chemical reaction between the phosphorus and magnesium is already done. So the risk of the oxide magnesium reactivity with the phosphate is no more an issue because you will replace it with a phosphate where the two minerals are already inside of it and the reaction is already done. So think about it. The phosphate, you must adapt it to what will be the final product you will incorporate it. To conclude about this third part, we need to say that the minerals interaction can reduce the digestibility if not controlled. So the recommendations are minimize the calcium complex formation, for example, by using Humifora, a calcium homophosphate, to limit this complex and help to have a better vegetal phosphorus digestibility in monogastric. And finally, adapt the phosphate to the final product, such as prioritizing MDCP, Neophos, MAG26, or DCP for mineral feed or premixes. Thank you very much for your attention, and I will be really happy to answer any questions. Je coupe mon micro.
Thanks a lot, Margot, for your presentation and for sharing us your expertise. It gives us an overview of the crucial role of minerals on animal diets. So now we will start the Q&A session. So I think we have first question about phytase enzyme that is widely used to release phosphorus that is on phytic form. Can this enzyme can act also on the calcium phytate complex?
Hello, Joseph. Thank you very much for your question. So the phytase enzyme are in fact disturbed. Their activity are disturbed by this calcium phytate complex. Today, there is new generation of phytases that are able to work a little faster in the stomach in order to be less disturbed in the intestine. But still, they are not able to liberate all the phosphorus from phytic acid in the stomach. And then when the fetus wants to cut again the phosphorus inside the intestine, this calcium phytate complex will not allow it. So even with normal generation or new generation of fighters, the fact that when they reach the intestine, the calcium phytate is going to disturb the phytase activity.
Thank you, Margot. So about fighters and this complex, you talk about a product, Humiflora. Can you tell us more about this product?
Yes, of course. So Humiflora is a new patented innovation in macroannuals and phosphate. It comes from a chemical reaction between phosphoric acid, source of calcium, and humic substances. But it is not only a source of phosphorus, but a solution that will promote the digestion of the nutrients, such as the vegetal phosphorus, thanks to these chelating properties with the calcium, limiting the formation of calcium phytate complex. So it's really like a synergy, in fact, with the fighters in order to help the total phosphorus digestion inside the gut.
Thank you, Margot. Next question, for mineral and premixes, is it possible to use all the sources of phosphorus mentioned in the presentation in just one product?
For mineral and premixes, is it possible to use all the source phosphorus mentioned in presentation in one product? If you talk about phosphates, today you have two kinds of products that will have combined mineral inside of it. So you have the neophos, that is a calcium sodium phosphate, where in fact you have in one the supply of calcium, sodium, and phosphorus. You have also the MAC26 that will provide magnesium and phosphorus, but no calcium. And if you want, sometimes, yes, you can make a combination, but depends if you have one or two silo. Most of the time, we recommend one phosphate use because there is one silo for phosphate. So the best is that to adapt really the phosphate depending the problematics or the final use of the feed.
Okay, thank you. The next question is about the need of phosphorus for the rumen of cows. Why is the phosphorus requirement of the microbes not taken into account for the supply of the dairy cows, but contained on top?
So in fact, in the requirements of the cows, there will be a total requirement. Here, we just separated the three of them in order to explain what will be the recommendation for the maintenance, the rumen, and the milk production.
Now, what is your opinion about using MAP with fix-up in ruminants?
So the use of monoammonium phosphate with a buffer solution can be useful in order to have a better functionality of the rumen bacteria inside the gut. So yes, most of the time we can recommend to have a buffer solution additionally to phosphate that brings ammonium.
Okay, thank you. If there is other questions. Okay, not yet. So I have another question for you, Margot, about phosphate. How we can measure the quality of a phosphate? Sorry.
So regarding the quality of a phosphate, to characterize it, today we have talked about the phosphorus water solubility, but it is not the only parameters to take in account in order to characterize the quality of a phosphate. You will take in account as well the solubility of phosphorus in citric acid and the phosphorus solubility in alkaline ammonium citrate. The solubility in citric acid will stimulate the gastric conditions and the nutrient solubilization. The higher it is, the better the quality of the phosphate is. The second parameter is the solubility in alkaline ammonium citrate. It will give an indication of the proportion of TCP molecules, so tricalcium phosphate molecules, that are non-digestible phosphorus molecules. So the aim of this last parameter is to be as high as possible because it will reflect a low proportion of TCP molecules inside the phosphate.
Okay, perfect. Thank you. Do you have any questions? I have another one for you. Sorry, I think yes. What's the impact of MCP on monogastric gut pH, and what are the limits when using MCP?
So using MCP in monogastric will be in fact the best phosphate to recommend. Why? Is because the pH of MCP is between 3 to 4. So it is adapted to the gut pH of a monogastric. For example, for poultry, we have a pH between 2 to 3. So the lower is the pH of the ingredients, the better will be the solubilization. So I will say there was no limits of using MCP, just taking in account the requirements of the animals. So taking in account how much phosphorus you bring through the MCP, what is the digestibility of the MCP, and then what are the other components inside your diet if you are bringing soya, corn, wheat, and what to take in account is in the vegetal source, such as corn, soya, taking in account the phytate composition that can fluctuate from one source to another.
Thank you. So another one. What is your opinion on the usage of bovine bone and meat meal in poultry feeds? For example, in Pakistan, most of the feed mills are using it. So your comments on that regarding phosphorus availability or any other remarks?
That's a good question. So the bone meal or meat meal are also a source of phosphorus, but the fact is you have a higher variability in terms of digestibility from one source to another compared to inorganic sources such as feed phosphate that you have a standardized composition of phosphorus. So even if the bone meal can be maybe cheaper, you have a risk that the composition that you are expected from your bone meal or meat meal can vary a lot from one source to another and from one batch to another.
Thank you, Margot. Do you have any other questions? So I think it's good for everyone. I would like to thank again Margot for her presentation and her expertise. Thanks all of you to attend this session. So see you soon, maybe on the next webinar, and have a good day. Thank you.
Thank you very much. Have a good day.